In this video, I will discuss the process that we need to use to find the principal axis. So when we have L rotational equals I times omega, we said that I is a tensor or a 3x3 matrix, and we represent the two vectors as 3x1 matrices. Now, if I want the result, okay, if I want L rotational to point in the same direction as omega, then the result, when I do the multiplication of the tensor I with the matrix omega, then this needs to give me a number times omega. Okay, this k needs to be a number so that I can say L rotational k omega points in the same direction as omega. Okay, so we know from introductory physics, if you take a vector and you multiply with a number, then this product will point in the same direction as the vector omega. So to find the principal axis, it needs to be true that I omega equals k a number times omega. Now, to move on from this, I'm gonna do the following. I can use the unit matrix that I will call, so with this symbol 1, I am using the unit matrix, and what that means is 1, 0, 0, 0, 1, 0, 0, 0, 1. If I take this matrix and I multiply it with k, then I get k 0, 0, 0, k 0, 0, 0, k. I'm just changing the 1s to k. And when I multiply that with omega, essentially I get the same result as k, the number times omega. So I can say k, a number, times the 1, the unit matrix, the identity matrix, times omega. Okay, I'll make a note just to make it clear. This is referring to a number, and this is referring to a matrix. Now, what I'm gonna do, I'm gonna move everything to the left side, so it will be I times omega minus k, the unit matrix omega equals 0, and then I will take out omega as a common factor. Sorry, this is 1. Now let's take a look at this. This is, as I said, this is a 3x3 matrix. K is a number. This refers to another 3x3 matrix. Okay, so a number times a 3x3 matrix will give you a 3x3 matrix, and it makes sense to subtract a 3x3 matrix from another 3x3 matrix, and this omega is a 3x1. Now, when you do all of this at the end, you should get a 3x1 matrix. All right. Now, in order, okay, why am I doing this? This equation, which is really 3 equations, since I have three rows, x, y, z. So this equation allows me to find the principal axis. So I'm doing all of this work. Okay, all of this work is so that I can find the principal axis. And why do I want to find the principal axis? Because I know if I know those 3 principal axes, and the angular velocity points in one of those directions, then the angular the rotational angular momentum and the angular velocity will be pointing in the same direction. Now, in order to solve for omega, which will give me the principal axis, it needs to be true, and this is something that we know from linear algebra, the determinant of the 3x3 matrix I minus K1 needs to be 0. Because if this determinant is not 0, then you can find the inverse of this, and essentially your omega will give you 0, 0, 0. And 0 is not a helpful solution. So it needs to be true that the determinant of this needs to be a 0. Now, the way that we're gonna do that, once you set up your 3x3 matrix, you will find the determinant, and your determinant will include one unknown, k, and it will be to a cubic equation. It will have k to the 3, k to the 2, k to the 1, and probably constants, and that equation needs to be solved, and from here you're gonna have 3 values for k. Okay, let's call them k1, k2, and k3. These 3 are what we call the eigenvalues. Okay, this particular kind of problem, so when you see something like this, a matrix times a vector equals a number times the vector, this is what we call an eigenvalue problem. An eigenvalue problem, an eigenvalue equation. And when you find the 3 numbers that correspond to this k, the 3 numbers for which this statement is true, this equation is true, then we call these 3 numbers the eigenvalues. Now, once you have those 3, you're going to do the following. You're going to take k1, and you're going to go back to your original problem. So you'll have I times omega equals k1 times omega. I'm going to use the subscript 1 from here. From this equation, now that you have the 3 numbers, now that you know k1, from this equation, your goal will be to find omega 1. And this is going to be one of the 3 principal axes. Let me remind you, back here in this eigenvalue problem, you knew neither k nor omega. Okay, so from this problem, we were looking for both what k is and what omega is. Now, by setting the determinant to 0, we're going to find the 3 values of k for which this is true. And the last thing we need is to know what is the omega for which this equation is true. And once you find your first principal axis, you're going to do this again. I omega 2 equals k2 omega 2. And this is going to give you the second principal axis. And of course, you're going to do this one more time. And you will find your third principal axis, and that is it. You have all 3 principal axes, and you know if your angular velocity vector is one of these 3 principal axes, then the rotational angular momentum will be pointing in the same direction. And referring to the eigenvalue problem, we call these 3 solutions, okay, these were the eigenvalues. These are what we call the eigenvectors. Okay, so when you have an eigenvalue problem, you're looking for 2 things, the eigenvalues and the eigenvectors.